Right, so we're dealing with circles here, and we're dealing with arc lengths, which are part of a circumference. Okay, circumference of that circle would be all the way around. The arc is the curve that goes from P to Q, which is going to be a part of, a fraction of the full circumference of the circle. It's higher tier. They're going to assume that you know that the formula for the circumference of a circle is 2 times pi times r, and they're going to assume that you know that the formula for the area of a circle is pi times r squared. You got to know those. Right, and so long as you know those, then it's fairly straightforward to be able to access these questions. So we've got a circle with a radius of 8.2 centimeters. An angle POQ, P to O to Q, is 46 degrees. Now we want the length of the arc PQ. So what we've got there is a slice, a fraction of the full circle. And we know that the full circle has got an angle of 360 degrees. So the slice that we're working with is 46 out of 360 degrees. So the slice that we're working with is that as a fraction. And once we know what that is, then we want that fractional part of the circumference of the circle, which is 2 times pi times 8.2. So if that question was, in a foundation tier paper, it would be, what's the circumference of the circle, which would be 2 times pi times 8.2. Because this is in a higher tier, they don't want the whole circumference, they want a fraction of it, and the fraction that they want is 46 out of the full circle, 46 degrees out of 360. So bringing that onto your calculator then, what we've got here, a bit more space, is lots of different ways of putting this on your calculator. The way you're most likely to do it, I think, would be you would write a fraction 46 over 360, and then you would do times 2 times. Now you could type 3.14 in there, or you could use the pi that's already stored in your calculator. Up to you. If you're going to use the pi button, then it's shift and that, and you'll see that the pi symbol comes up, times 8.2. but if you wanted to just put 3.14 in there, you could. Work out equals, and you see that that is 6.583333. The radius is given to 1 decimal place, so we need to give our answer to 1 decimal place. 1 decimal place is the 5, but the next digit is larger than 5, more than 5, so that would round up to 6.6 centimeters. The second part of this question is talking about the area, and it's exactly the same. We want now the area of that little slice there. So we don't want the area of the full pi, the full 360, we want this fraction of it, and we know that the area of a circle is times pi times the radius squared. And again, on your calculator, cancel the last one, fraction 46 out of 360 times pi times 8.2 squared equals 26.99 to 1 decimal place. The 9, the next one, means it rounds up, which would be to 10, which means that becomes 27.0 to 1 decimal place centimeter squared. Okay, so whether it's arc length or area, it's basically your two standard formulae for circumference and area, but you're multiplying it by the fraction of the circle that you were dealing with. So if we take a look at the second one, same situation. So we've got a circle with centre O, radius 6.2, G and H lie on the circumference, and we want the length of the arc. So this time my fraction is going to be 130 out of 360. It's not the area, it's the arc length, so times 2 times pi times radius. So cancel the last one. 130 out of 360 times 2 times pi times 6.2 equals. Turn to decimal, and to one decimal place that would be 14.0. Next one's more than 5, so it rounds up to 14.1 centimeters. So the same again, what fraction of the circle are you working with, times either the formula for the area or the formula for the circumference.